All right, we move on to the work from 6.4.1. For each system below, decide which algebraic solving strategy to use. That is, which method would be most efficient and convenient, the substitution, elimination, or setting them equal to each other, which is known as the equal values method. Justify your reasoning for choosing one of the strategy over the others. Okay, our first one says x equals 4 minus 2y, which is essentially slope-intercept because there's one variable isolated, and it doesn't have to be y. And then 3x minus 2y equals 4, so that's more standard because it's ax plus by is equal to c. So because x is alone, we know we can plug it in right there. So that would be, plugging in would be known as substitution method. And our reasoning is that x is isolated, so we can plug it into the standard form. In equation 2. And typo, equation. Okay. We'll save the solving for the next video. Right now we're just setting stuff up. Okay, B. 3x plus y equals 1. 4x plus y equals 2. Well, these are both totally standard, right? ax plus by equals c. ax plus by equals c. In this case, our chosen method would have to be elimination, because what we'll do is we'll find a way to eliminate either the x or the y. To me, it looks like probably the y. But you'll call that elimination method. And the reason that works is that you can add the two systems together once you've multiplied one of them to get opposite coefficients, and then you can eliminate one of the variables. So you can eliminate one of the variables by getting opposite coefficients on that variable. And of course you'll do that by multiplying the equation. Okay, C, chosen method. Here we have x equals negative 5y plus 2. So that's sort of a slope-intercept. Even though the x and y have changed position, we still have an isolated variable. And then our second equation says x equals 3y minus 2. Well, what I notice is that even though it's not in y equals mx plus b, we still have the same variable, x and x isolated. So it's probably best to use the equal values method, because the same variable is isolated. In both equations, so we can set the equivalent expressions equal to each other. Just to demonstrate what I mean, if this expression is equal to x and this expression is also equal to x, then they must be equal to each other, which is the whole point of the equal values method. Okay, D, 2x minus 4y equals 10, 2y plus 6 equals x. Okay, this for a second is going to appear to be standard and standard, but if you notice here, x is actually alone over here. So this could also be understood to mean x equals 2y plus 6. So this is really sort of a slope-intercept version. So what I would do is I would take this, the 2y plus 6, which is equal to x, and I'd plug it in where I see x, and therefore I would eliminate the x. So what I'd be doing by plugging in is substitution. And the reason I would do that is that x is isolated in one equation, so it can be substituted for in the other equation. Simple as that, and then you'll solve it. The key here, of course, was noticing that x was alone, even though it appears it sort of is trying to trick you into thinking it's standard. The x is all alone over here. Okay, next, E. We have D equals 2 times 7 plus W, so we're going to be asked to do some distribution. And then we have 3D equals 15T minus W. All right, this is tricky because we've got 3 variables. But what I would do is I would recognize that if D is alone, I can substitute this value for D here, and then I can solve for W because there would be no D. I think that works better than doing equal values method. So I would say that since this is alone, I can substitute that in there. I could also divide this one by 3 on both sides and do equal values method, but I'm going to choose substitution.